Lesson 8, Multiply Decimals. In this lesson, we will talk about keywords for multiplication, review whole number multiplication, talk about partial products method with decimals, the area model methods with decimals, fractions with decimals, and we'll look at the standard algorithm with decimals, just so that you have everything you might need. Here are the multiplication keywords, and trust me, there are more, but these are the ones that I could remember. So some of them are a little obvious, like times and multiply. Others are a little harder to remember, or they show up in other operations. Each and every shows up in division as well. Per, of, those are ones that kids often miss. So just be on the lookout for these words. There are also others that are not on this list. So as we move into decimal multiplication, we're just going to go over the multiplication with whole numbers, and we explored several. We talked about the area model, partial products, and the standard algorithm. So area model for something like, let's keep it simple, 12 times 123. Let's keep it simple. So, area model, we would simply set up our box there and split up our numbers by their place values, and we will do the same thing with decimals today. So if you're really good at this model, then you will be really good at the decimal model. So here I set us all up. 10 times 100 is going to be a 1 with 3 zeros. 1,000. This is going to be 1 times 2, so that's going to be a 2 with 2 zeros. And 1 times 3 with 1 zero. Do the same thing to the bottom numbers. We have 1 times 2 with 2 zeros, 2 times 2 with 1 zero, and 2 times 3, no zeros. So in total we have 1,230 on the top, and we have 246 on the bottom, and we can add up our partial products, and we get 6741 as our answer. So that's the area model. Let's take a look at the partial products method. Let me get a bigger eraser. Okay. Get that erased. So we should see very similar numbers when we're doing the partial products method, because it's the same thing as the area model, but without the picture. So we have 123 multiplied by 12, and so we're going to do 2 ones times 3 ones, 2 times 20, and then 2 times 100. I'm running out of space, so I'm going to go over here to do my 10. This is going to be 10 times 3, 10 times 20, and 10 times 100. As you can see, they're the exact same partial products as the area model. So when you find all of these and you put them all together, you should get the same answer. 200, 1,000. This would be 246. So based on what I have here, I know I should have, once again, this time I'm going to have 1,230 plus 246, which will equal 1,476. The exact same thing. Okay, let's do one last method. We have the standard algorithm, our last method, which we will look at for decimals for fun. As I clear this up. Alright, so the standard algorithm is one of our faster strategies. And here we go. 2 times 3 is 6. 2 times 2 is 4. And 2 times 1 is 2. Oh wow, doesn't that look familiar? 246, I've seen that before. I put my 0 here because now I'm multiplying by 10. So it's 1 times 3 will give me that 30. 1 times 2, we'll put the 2 in front of it. And then the 1 times 1 is going to give you that 1,230 that we've been seeing. And when I add up those partial products, you guessed it, it is 1,476 is your total. Okay, so those are our methods just for review. And let's move on to the decimals. Oops, there's a whole number. So this is from the homework. This is number 5 from the very first page. I just wanted to let you all know, if you're struggling with this particular problem, there are actually 2 different problems in it. So a pet store sells dog biscuits and cat treats. There are 2 things going on here. The store has 27 boxes of dog treats and 21 pouches of cat treats. Each box holds 18 dog biscuits, and each pouch holds 24 cat treats. Are there more dog biscuits or cat treats in the store? So you're going to have to do 2 separate problems. You're going to have to put the dog treats in the boxes, so 18 and 27, because those are the dog treat numbers, and then you're going to have to put the 24 cat treats into the 21 pouches, which is just a really, this is another word for bag. So you can imagine that. 21 bags of cat treats. So there are 2 different problems here, 2 different ones to do, 2 different multiplication problems to do. So just in case you were getting confused by that. Alright, here is the first decimal page. The previous pages were for whole numbers. So in the example, they're showing us how to estimate. And the reason why we estimate is because, frankly, sometimes it's way faster just to do a really good, quick, educated guess. This is what we do in the store. When we see that something is $2.99, we automatically say that's $3. So that's the same thing we're doing here. We're rounding our number to the nearest whole number because whole numbers are easier to work with than decimals. And so we really just want to see what our answer should look like at the end. So you can see the 3 and 1700ths. Well, if I look here, I see 3 and I see a 1 sitting next door. The 1 lets me know I'm not that big. I can actually stay a 3. I don't need to go up to 4 just yet. So the 3 stays the same, and the 4 is already a whole number. So it became 3 times 4, which is 12. So we know that our answer should look like this. If it's 21, we're too big. If it's 2, it's too small. So we should have an answer very close to 12. That's what it means when they're asking you here, is it reasonable? Is it reasonable that the product is a little bit greater? Well, when we estimated, we actually went down. When we rounded down, we said, let's use 3 instead of 3 and 1700ths. So that means the real answer is going to be a little bit higher because it's not rounded anymore. So it is pretty reasonable that the answer is a little bit higher than the estimate. The estimate was rounded down. So the real one will be the opposite. It'll go up. And here's the first strategy what we'll use for decimals is the partial product strategy. So we have 3 ones being multiplied by, well, the first one here is the 500ths. So in total, that should be how many hundredths in total? What's 3 times 5? Good, 15 hundredths. The next one is 3 ones times how many tenths? 3 tenths. So 3 times 3 is 9 tenths. And if you remember 9 tenths, looks like this. If I pop a 0 on, it's now 90 hundredths. Okay, so if I put those two things in the boxes, 15 plus 90 hundredths, there we go, we have a total of 105 hundredths. And if we remember from previous lessons, we want that 5 to land in the last name. So that means 5 is in the hundredths place, the 0 is in the tenths place, and the 1 is in the ones place. Okay? So that is how we use the partial products method. It is really, really important that you put the words after. These are not whole numbers, and that'll change things. That is going to change the way we look at things. As I'm going to show you later on with fractions, those words really mean a lot. Okay, let's keep going. Here's where we can really put that estimating into practice. So this one says write the decimal point in each product, so the answer, that's the word for answer, so that the equation is correct. So what we're going to do is actually, I'm not going to do all the multiplication for this problem. That would be absolutely ridiculous. What we're going to do is just round and use whole numbers instead. So keep the whole numbers that we already have. You can see them throughout. Okay, and we're going to say, well, 6 times, I wonder what this would round to. Well, I see there's a 2 next door to the 8, which means it's not that big. I remember the rhyme, for or less, give it a rest. Let it rest. So it's going to remain an 8. So that's going to let me know that this really is 6 times 8. Well, what's 6 times 8? If you said 48, that means you're practicing your multiplication facts. Good for you. That means we're going to put our decimal point right where it would make sense for that to say 48. Of course, it says 49 instead because we rounded down, so the real answer is higher. But where should our decimal go so that it looks very close to 48? Well, if I put it here, it looks like 497. That's way too big. If I put it here, it looks like the number 4. That's way too small. But if I put it right here, it looks just like 6 times 8, which is 48. So I'm going to put it here so that it looks like 49. That's close enough. I'm going to do the same thing for B as well, and then I'll let you do C and D on your own. So I see here, this is the whole number, which is 0, and there's a 5 next door, and 5 or more, let it soar. That's going to actually round to 1. And I'm going to multiply that by 5. 1 times 5 equals, well, that's an easy one, 5. So where should I put the decimal point so that it looks like 5 wholes and not 26 or 265? Behind the 2 is the correct place. So make sure you put your decimal right behind the 2 because 2 is close to 5. So do the same thing for C and D and you'll be good to go. For number 7, This particular problem, I just wanted to let people know what the other number was. I know this is really difficult for some of us when we're reading our word problems. So in the city where Sonia lives, it rained an average of 4 and 5/100 inches each month last year. About how many inches of rain fell in all? So we got a lot of information in here, and one of our numbers is actually hiding. I know you see this number. Does anyone know what the other number might be? It's actually hiding right here in this phrase. Each month last year. How many months are in a year? 12. So now that you have both numbers, you can get started on your multiplication. Okay? So I'll leave you to it. Here's the area model for decimals. So we're going to complete the area model. We have the 1 and 5/10 is already there, but we're missing our 2 on the side and the 3/10. We need to have that. So we have 2 times 1 is 2. That makes sense. And then 2 times 5. Well, I know what 2 times 5 is. That's 10. But this is not just 5 wholes. This is 5/10. So that means now I have 10/10. Well, if I have 10 of them, I know that my decimal point has to make the 0 land in the 10th place. So I'm actually going to write that properly. Give me a moment. I'm going to write the whole equation because that's what you're supposed to do. You're going to write 2 times 5/10 gives you 1 and 0/10, also known as 10/10. You can say it both ways. Okay, let's go down to the bottom. We have 3/10 times 1, and that's an easy one. Anytime you multiply by 1, you keep the same number. So that's good. And then we have 3/10 times 5/10. Now here, I'm sorry, my pen is not as good as it could be today. Here's where things get a little bit tricky for our 5th graders. You guys automatically always want to say, okay, well, I see 3/10 times 5/10. I know 3 times 5 is 15. But what we always forget is decimals are only pieces of numbers. And because of that, when you multiply a decimal by a decimal, it actually gets smaller and smaller and smaller. So 3/10 times 5/10, well, you see those 2 place values there? You're going to put them together. And your answer has to have those 2 place values. And so your decimal ends up right in front. And that particular box is 15/100. We have tenths times tenths makes 100. Because 10 times 10 makes 100. So let's put it all together, and we're going to use we're going to be very, very organized with the way we line up our numbers. So we have 2, which is in the whole. So I'm going to actually set up a little place value chart just to help me keep my numbers in order. So here's my decimal point. Oh, it's a little off right there. So I have 2 wholes, and then I have 1 that came right after it. And those both have no tenths or hundredths in them. And next there's a 3/10. So that's going to get a spot right there. And finally we have 15/100. So there's 1/10 and 5/100. Now I'm ready to add. I'm only ready to add when I know that my numbers are perfectly lined up. 0 plus 0 plus 5 is still 5. 3 plus 1 is 4, and 2 plus 1 is 3. Bring down my decimal as I learned in the last lesson, and my answer should be 3 and 45 hundredths. And I'm going to check that really quickly. 3 and 45 hundredths. And that is correct. So same ideas from the whole numbers. There's just a little bit of trickiness here when we start to multiply decimal by decimal, but we'll get the hang of it, don't you worry. So based on what we talked about in the last problem, you can use any strategy you like to finish this problem, and it's going to help set you up. So the Barker School grows lettuce and other vegetables for school land use. The school garden is 8 and 4/10 meters long and 6 and 4/10 meters wide. The section used to grow lettuce is 2 and 2/10 meters long and 8/10 meters wide. How many square meters of ground does the garden cover? That's a little question right there. Oops. Let's underline it. And how many square meters of the garden is used to grow lettuce? So there are two questions here. That means there's probably two things to do. So the first question is just about the garden itself, the whole thing. So these numbers that are in yellow are just for the garden. So that's your first multiplication problem. And then the numbers that are in green are all about the lettuce. And that's the second multiplication problem. Choose any strategy that you've learned so far to complete the problem. And this is number 5 from the very, very last page. And I really like this question, especially when kids see what it's asking you to do. So I'm just going to break it down so that everybody understands. Terry lives 9/10 kilometers from school. He walks back and forth to school each day. How many kilometers does he walk to and from school each week? Okay, so I want you to think about you getting to school. If Terry, I'm going to just draw a picture of a little Terry. He's going to school how many days in a week? We only go to school for 5 days a week. Thank goodness for those weekends. So we know that he's going to school on Monday, Tuesday, Wednesday, Thursday, and Friday. So how many times is he walking? The distance to get to the school and to go back home. So I know he walks one time in the morning and he walks back home. He goes to school and walks back home. He goes to school and walks back home. Goes to school, walks back home, goes to school, and walks home for the last time that week. How many times did he walk that distance? When you figure that out, you'll know what your other number is. So your first number is certainly 9/10. But what is your other number? How many times does Terry have to walk that distance? When you have that figured out, you'll be good to go, and that question is yours. So just to review each strategy, I'm going to show you partial products with my pen here. a little bit bigger. Alright, so let's say the problem is 25 hundredths times 5. So the partial product method is going to ask that I put my numbers vertically just so that my brain doesn't get confused. Okay, and I'm going to change colors so that things are really clear. So my first partial product is going to be 5 ones times 5 hundredths. So I could either write it in number form or write it with words. So I'm going to write it with words just so you can see what I'm doing. 5 hundredths. I'm going to just use the first couple. No, I'll use the whole word. Hundredths. Such a long word. Okay, so 5 times 5 is 25. But because of this word, that lets me know I'm multiplying by hundredths. So this should be 25 hundredths. So I'm going to put a decimal right in front of it so that the 5 lands in the hundredths place. The next partial product will be 5 ones times, well, I have two options here. I can say 2 tenths or 20 tenths, 20 hundredths. So I can either say 2 tenths or 20 hundredths. Well, I'm working with hundredths, so it might be better for me to say hundredths. There are 20 of them in that problem. I'm going to keep it tenths just so everyone understands what I'm doing. So 5 times 2 tenths. And then I'm going to make it look like hundredths. So 5 times 2 is 10. Okay, so I have 10 tenths. Or 100 hundredths. Well, I know that 0 has to land in the hundredths place, which means this one's in the tenths place, which pushes that 1 into the ones place. So when I line up my digits, I'm going to get a really good addition problem. I'll have 25 hundredths plus 1 and no hundredths. 2, 1, and there is my product. So that is how you do the partial product method. The same way you did the whole numbers. Here's the area model with the same problem. We had 25 hundredths times 5. Again, I'm going to split up my numbers by their place value. So I have 2 tenths and 5 hundredths. Here we go. So I have 5 times 2 tenths. 2 tenths. Well, if I have 2 tenths plus 2 tenths plus 2 tenths plus 2 tenths plus 2 tenths, that's going to give me 10 tenths. The 0 is in the tenths place, so that pushes the 1 to the ones place. That's 1 whole. Here's my next problem. 5 times 5 hundredths. So again, that's going to be repeated addition of 5 hundredths. So that means it'll be 5 times 5, which is 25 hundredths. You can imagine those hundredths blocks that we use in class. And I'm going to give 5 to 5 students. How many did I give out in total? 25 hundredths. So I'm going to make sure that 5 ends up in the hundredths place, and the 2 falls in the tenths place, and that means the decimal falls right in front of it. So I'm going to line up my numbers and add them up. So that's going to be 1, goodness, that needs to stop happening, 1 whole, and no hundredths, plus 25 hundredths. And that's going to give me, oops, too fast, slow down, 1 and 25 hundredths. Let's look at 1, let's see what other model we have. We have fractions. Fractions are amazing. So I'm actually going to show you how to use fractions with the area model, just in case you get a little confused. So I still have the same problem at 25 hundredths times 5. And I know that this 2 is in the tenths place, so I'm going to call it 2 tenths. And I know there's a 5 in the hundredths place, so I'm going to call it 5 hundredths. And whenever you have a whole number, there's actually a secret number 1 on the denominator. We just don't say it all the time, but there is a 1 when you have whole numbers. So I'm going to set up my problem here. I have 5 wholes, 5 ones, multiplied by 2 tenths. Well, I'm just going to multiply straight across. I actually want to switch colors for this. That might make it easier. I'm just going to multiply straight across. So 5 times 2 is 10, and 1 times 10 is 10. And if you know anything about fractions, if the number on the top is the same as the number on the bottom, that means it equals 1 whole. So for this box here, the answer is 1 whole. Okay? I'm going to do the same thing over here. 5 ones multiplied by 5 hundredths. Okay, I'm going to do the same thing. We're just going to multiply straight across. So we have 5 times 5, which is 25, and 1 times 100, which is 100. Okay, and I'm going to put that back in decimal form. 25 hundredths is 25 hundredths. Who would have guessed? So if I have 1 whole and 25 hundredths, you should still line up your decimals no matter what. 1, always do the good habits. And 25, I wonder what that's going to add up to. 5, 2, and 1. So the answer is 1 and 25 hundredths. So fractions can be really great, especially when we get to decimals times decimals. You're going to see that 10 times 10 is actually going to change it to hundredths. So tenths times tenths equals hundredths. I really, really love the fraction method when we're first learning about this. And here's the standard algorithm. So I will set up our problem. It was 25 hundredths times 5. So with the standard algorithm, this is what we do. We simply count the number of decimal spots that we've used, and almost like we're ignoring them for a little bit. So we use 2 spots. We're going to take them out and ignore them. We're going to treat this like whole numbers. We're just going to act like the decimal doesn't exist. So I know that I've only had 2. If there was a decimal here in the 5, I would put a 1 over here, but there's not. So 5 times 5 is 25. And we're going to compose the 2. 5 times 2 is 10. And we're going to add in what we composed, so that's going to make it 12. And this is when I put my decimal back in. So I know that I took out the decimal and I took out 2 spots. We're going to put them back in. So 1, 2, and that's where it goes. And our product is 1 and 25 hundredths. So there's lots of different ways to multiply decimals, especially based on comfort. You may feel really comfortable with the standard algorithm or not. You may love the area model. Whatever choice you make, just make sure that you're lining up your decimals when you're adding and checking those multiplication facts, and you should be okay. In this lesson, we went over keywords. We reviewed whole number multiplication. We talked about partial products, area model, fractions, and standard algorithm with decimals.